We have a truck driving down the road at 15 meters per second and it weighs 1,000 kilograms. If the air resistance is 300 newtons, what's the power required to keep it going at this speed for a level road and for a hill at 22 degrees? Now power is just force times velocity. So we can write power equals FV. Now the force that we're trying to overcome is the air resistance, 300 newtons. So we have to put in 300 newtons at 15 meters per second, the velocity we want to keep it at. So we plug that in as 300 is the force, the velocity of 15, multiply that through. 4,500 watts of power will keep this truck going at 15 meters per second. Now we want to do this for an angle of 22 degrees. Now the easiest thing to do is define our x and y axes a little differently. Put y this way, and we'll put x this way. Now the reason we do this is because most of our forces are going to be in this direction. So we don't want to be using sines and cosines for everything. We'll just have to use it for one thing this way. So I'll draw out the truck and show you. We have the truck here going up like that. Now I'll just put the forces on it here. The weight acts straight down. That's the weight. And that's the force we're going to have to break up into its components. The other forces acting are the air resistance force, which is acting straight back in our new x direction. And we have the normal force that acts straight up in this y direction, because this normal force acts perpendicular to where the wheels touch the ground. So that's why it acts like that, as opposed to straight up like the weight. The weight will go straight down because that's the way the weight acts, but the normal force is perpendicular to where it touches. So the last force we have to add is our driving force. That's the force we need to overcome the air resistance, so that all these forces cancel out and we're left with zero, so we stay moving at the same velocity. So what we're going to do is we're going to sum the forces in the x direction, and it'll equal 0 because there's no acceleration. Now what we have to do is we're going to have to break this weight up into its components. So all I do is I split it up, I make a little triangle, put the W on this side, break it up into a triangle, so that this is in the y direction and this is in the x direction. So this force acts downward in the negative y and back in the negative x direction. So we're summing the forces in the x direction. Let's put in the forces we know. Plus Fd, we have minus Fa, and we have just the weight, just this portion of the weight here. And that's going to be minus, because it's going in the negative direction. And we look at this, if we look at these angles, this is 22, if we had extended this is 90, makes this 90 minus 22, this whole thing is 90, this one in here is 22. This one that I'm coloring in here. That's a 22 degree angle. Now if that's a 22 degree angle and I want this, I know that this is my 90 degree, this is my hypotenuse here. My hypotenuse is the weight, so I'm going to use sine to get my x-axis, to get my x weight. So W sine 22 degrees, and those are all my forces in the x direction, equals 0. I'm looking for my driving force, so I'm going to put everything on the other side. Fa adds to the other side, W sine 22 degrees adds to that side. The force from the air is 300 newtons. The weight is m of 1,000 times g of 9.8 times sine 22 degrees. So I just multiply those, add up to 300, and that gives me a force of 3,971 newtons. That's the force required to keep this truck going. That's not our final answer because we're looking for the power. Now that we know the force to overcome both the air resistance and the weight, because what we're basically overcoming now is the weight. Power, again, is force times velocity. The force is 3971. The velocity is 15. Gives us a power of 59,565 watts.